My name is Indrajit Roy, and I work in HP Labs. And this is a project with which I'm collaborating with Vertica as well. So I'm going to tell you what we have been working on the last 2 years on improving and extending R. So a lot of customers come to us, HP in general, and Vertica in particular, asking about what they can do with their big data problems. One such problem is listed here. So here's a customer which came to us and said that they have billions of rows of transactional data, and they want to use it to figure out what are the mortgage rates that they should give or what kind of loan rates that should be given to these customers. The problem is that to answer this question, you need to do something different. You need to do regression analysis, so something which is not just SQL. And they can store the data, of course. They can try to regression using their custom code, but this all takes a lot of time. And if you just look at traditional databases, they don't support these complex algorithms, regression in this case. So what I'm trying to motivate is a platform which allows you to perform these interesting predictive analytics very quickly. And if you look at the big data problems that people see, one is, of course, how to store managed data. But the bigger problem is people don't even know what is the question to ask and what and how they can monetize on that data. That question I cannot answer, but a lot of data scientists can answer. And many of them have, for example, Facebook has pointed out, there are a lot of things that they have figured out. From Netflix is interested in movie preference. Others may be interested in mortgage rates. Some want to know whom to follow. So these are the questions that you really want to ask the big data that you are collecting. But the answers to these questions are not necessarily very simple, because some of these require complex algorithms to be run on large amounts of data, and that too pretty fast. So if you look at Google, Bing, Facebook, and others, some of them use PageRank. Others, like Netflix, require recommendation systems. Then there are graph algorithms, which are used by Zing and others. Many of these, if you look deeply, are machine learning and graph algorithms. There are various ways to solve these problems, but one particular way, which has been around for a while, is to actually look at them as linear algebra operators. So if you had a system which can do linear algebra very well and very easily, then you could run it on big data, get your answers back very quickly and efficiently. So in fact, we don't have to really start with a system on our own or recreate a system, because there are already languages which have been around for decades which do this very well. One such example is R, which is open source, millions of users, thousands of packages. Anything that you want in machine learning and graph algorithm, it's already probably there, so you should just be using it. The problem is it's single-threaded, doesn't scale. That is the only issue with it. So if what we have been working on in the last 2 years is really trying to see, can we push the frontiers of R and make it scalable? This is a very simplified diagram. It's not even like technically correct, but it proves it's like gives you the point what we want to say. If you look at the scalability, there are systems like Hadoop which scale very well, but they're not efficient if you want to do anything interesting. So if you do search, sort, and other things, high throughput, it's all good. Relational databases, which somehow is not showing up well, that allows you to do SQL very well, scales better, much more efficient than Hadoop, which is one of the reasons why people are rewriting the MapReduce layer on top of it, on top of the Hadoop ecosystem. Then you have R and MATLAB, which are very efficient, array-based for machine learning graphs, doesn't scale. So my aim, or the aim of our team, is just to move that R and MATLAB like top leftmost thing to the top rightmost place, make it scalable. So we have a system which allows you to run distributed R computations. It has 3 goals, and which we think we have achieved. One is ease of programming. So it's not declarative, unlike SQL. It is very similar to the R itself. So it's an extension of R. So use the same syntax, similar syntax, if not the same. Use arrays. You can use packages that we have created. So the look and feel remains the same as before, if you're an R user, or you can write your own distributed algorithms, and we have been able to write them in like few hundreds of lines of code. These are few hundreds of lines of high-level code, by the way. So yeah, so it's easy to what we feel. Second is good scalability. So I did say that we want to run regression in terabytes, and then graph algorithms and billions of nodes and edges. All of that you can do in this system, and with only a couple of nodes or tens of nodes in many cases. Finally, it also has very high performance, because we have seen that you can run PageRank sharing in seconds. You can do regression in minutes and so on. My time is up, but I'll be glad to answer questions later on. Thanks.